All right. Before we go any further, I want to go ahead and kind of go over this Ferris wheel problem with you. Um, so I have the big cheese Ferris wheel, and the first thing I want to do is this is a really good way to kind of break down all of the different things that you need in order to be successful in calculating your Ferris wheel problem. So the first thing I want to know is what is the trip time? So as you can see up here, I was given a little bit of information up in the top. And if I look at that carefully, it tells me that I have 30 minutes. Now what that means is I have a Ferris wheel here, the diameter of my Ferris wheel, telling me that the platform is 23 meters. It also tells me that the whole height of the Ferris wheel is 130 meters, and what the 30 minutes represents is the amount of time it would take me to get on the ride and make one full rotation. So my trip time is 30 minutes. The next thing I want to figure out is how many degrees, this is going to represent my angle of rotation, how many degrees will I go in just 1 minute? So 1 minute is equal to how many degrees? So all I need to do is if I go around in one complete circle, that's 360 degrees. So I take 360 divided by my 30 minutes, and that tells me that for every minute that I travel, I go 12 degrees. So after 15 minutes, I would be 180 degrees. I'd be at the top of the Ferris wheel. Now, this will be important. You need to know how many rotations there are in a trip ride. When you do your project, it is possible that you might have a Ferris wheel where you actually go and rotate 2 to 3 times, in which case if I rotated 2 times, that would be 720 degrees, etc., etc. So, or you would divide, or a better way to do it was take 360, take that total trip time and divide it by 2. So I go 360 degrees in 15 minutes to determine the rotation. So the angle of rotation is 12 degrees. Next, I want to find my diameter. Now the diameter is just the diameter of the Ferris wheel. It does not include the stand height. So in order to calculate that, what I'm going to need to do is take that 135 and subtract out the stand height. So that's going to be 135 minus 23, which is going to give me a stand diameter of 112 meters. So I have 112 meters as my diameter. Now remember, a diameter is twice the radius, so in order to find the radius, I simply want to take that value and divide it by 2, meaning that I have a radius of 56 meters. Now this next one is very important. This is what's called the center height. The center height is the distance between the center of the Ferris wheel and the ground. So in order to find the center height, you're actually going to take the length of your radius and add to it the value of the platform. So in this case, I have a radius of 56 plus a platform height of 23. So my center height is actually 79 meters. So I'm going to attach this little graphic organizer all filled out for you. Just a quick reminder up here, I got this by taking the height of the Ferris wheel minus the platform in order to figure out what my diameter was. And so this should help you come up with these values. This will be important because as you go ahead and work out your project, you're going to need to know all these values in order to calculate them into your Excel sheet. So the first thing I want to do is kind of show you how you would do this if you were doing it by hand. So if I were doing this by hand, the first thing I would do is take my trip time, which starts off at 0 time all the way up to 30 minutes. And what I want to do is I want to divide this in equal increments. So a lot of times I'll do something where I might go, okay, this will be 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes, and then 30 minutes down here at the very bottom. I would like to see you use at least 6 or 7 increments. I can tell you the more increments you have, and in the Excel sheet, you're going to use every minute, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, etc., all the way to 30 minutes, or whatever the trip time of your Ferris wheel is. If your Ferris wheel, there are some Ferris wheels that take an exorbitant amount of time, such as, an hour. If you don't want to do 0 through 60, you can at least do 0, 2, 4, 6, 8, 10, etc. All right, and the next column in your spreadsheet is going to be your rotation time. Now your rotation time here is simply the amount of time it took times that angle of rotation. And remember, we said that that was 12 degrees. So this will be 0 times 12 degrees, which in this case is 0 degrees. Remember, when you get on the Ferris wheel, you're actually starting off at the ground. Next would be 0 times, other way around, it would be 5 times 12, 5 times 12, which would be equal to 60 degrees. Then 10 times 12, which is equal to 120 degrees, and you would do this all the way down until you got to 30 times 12. Now, when you do 30 times 12, you have 360. And we're going to talk about what happens here, because when you get down to 360, remember, you're in the same place you were at 0 degrees. All right, so that's going to be your second column. Keep this in mind. All right, so now what we're going to do is we're going to look at how we can find the vertical leg. The vertical leg is a two-step process. We take the cosine of the angle, this first one, and that's your rotation angle, which I'm getting from the second column, and then I multiply it by my radius, which is 56. So in this first case, it's going to give me 0, which makes sense because remember, I've just gotten on the ride and I haven't moved at all. Here, when I take the cosine of 60 degrees and I multiply it by 56, and you always want to make sure when you're doing your spreadsheet, it will actually deal, you can have it deal in radians, and we'll talk about that when we look at the project worksheet. But I'm dealing in degrees here just to show you, so I'm going to take the cosine of 60 times 56, and that's going to give me a height now of 28. So that's how far my vertical leg is. And then I'll continue this process all the way down until I get to the cosine of 360 times 56, which will also be equal to 0. So I want to go ahead and do that all right, so this last column is the most important column, and that is the rider height. Because when you go to graph your the image in your Excel sheet, you're going to use the first column, which is your time, and you're going to use this rider height. So what we need to keep in mind here is we're going to take the radius, which in our case was 56, and we're going to subtract the vertical leg, which in this case here, our vertical leg was 0. And then we need to add the platform height, because remember, the rider is actually already starting 23 meters off the ground. So when the person first gets on the ride, they haven't rotated at all, there isn't a vertical leg, and they are currently 23 meters off the ground. After 5 minutes, they've traveled 60 degrees. Down here it demonstrates that would be about 60 degrees. So you can tell you're a little higher than the platform. How much higher? We calculate by taking our radius, which is 56. We subtract the vertical leg, which is 28. We add 23, which is our platform height, and that's going to give me 51 meters. So yes, I'm a little bit further off, but I'm not quite as high as my center height. Of course, when I get to 90 degrees, then I would be at my center height. And then even all the way down here, if you're taking 56 minus 0 plus 23, notice that's your platform height again. All right, now each of these columns is on your project is going to be calculated using the spreadsheet itself. But I'm going to include this little graphic organizer because it might help some of you actually calculate some of your values. All right, I'm going to pause for a second. I'm going to keep this video separate in case you want to go back and look at it. I'm also going to include this graphic organizer in case that would be helpful. And then what I'd like you to do is you're going to go ahead and visit the video explaining the project itself.